Greetings to all. In this lecture, we are studying about linear congruences and how to solve the linear congruences we are going to study. A congruence of the form AX is congruent to B modulo M, where M is a positive integer. This M is a positive integer. This A and B are any integers. X is a variable. This type of congruence is called a linear congruence. So linear congruence contain three integers and M should be the positive integers. A and B are any integer, X is a variable. This type of congruence is called linear congruence. So your aim is find the value of X which satisfying this congruence. So what are the rules we have to remember for this? The linear congruence AX is congruent to B modulo M is solvable if and only if D divides B. What is a D? Where D is GCD, greatest common divisor of A and M. If D divides B, then the linear congruence has D incongruent solution. D number of incongruent solution we have. What is the general solution of the linear congruence? So this is another rule you have to remember. The general solution is X equal to X naught plus M by D times T. T is any integer. What is this X naught? It is a trial solution. Particular solution, a trial solution for X. If we know trial solution, then we can find out the general solution. And what are the incongruent solutions we have? The same thing only. X equal to X naught plus M by D times T. The same thing, but only here change. 0 less than or equal to T less than D. So T is an integer lies between 0 and D and including 0. Are the incongruent solution. So now we are solving this problem. Determine whether the congruence 12x congruent to 48 modulo 18 is solvable, and also find all the solution if solvable. What is the answer for this? First I am writing the given congruence. 12x congruent to 48 modulo 18. What is the A value here? Small a is 12. B is the remainder here 48. And M equal to 80. First we have to write this is our A, X coefficient. And this value is for B, and here modulo which number 18, it is M. Now we can find out D value. What is the D? We know that it is GCD, greatest common divisor of A and M. So A and M, this is a notation for GCD, which is equal to A value 12 and 18. What is the GCD of 12 and 18? You have to follow this concept. Any two number, no? 12 and 18. Which number, easy number you have to verify. Which number divide both the number easily. Both are even number. So divided by 2 possible. So 12 divided by 2 is 6. 18 divided by 2 is 9. Now again we will check which number divide both the number. 3 possible. 6 divided by 3 is 2. 9 divided by 3 is 3. So which number dividing these two number? Other than 1, no number. So now not possible. So only these two number you have to collect, which is equal to 2 times 3 is 6. So D value is 6. Now we have to check D divides M or not. D value 6, M value 8, B. D divides B or not. So D is 6, B is 48. So here D divides B. D divides B. this gives given congruence is solvable. If D divides B, then given congruence is solvable. Suppose D does not divide B, then it is unsolvable. Okay, so here D divides B and hence it is solvable. Now what is a particular solution or trial solution? Particular solution or trial solution. X naught. So you have to check this by trial and error. So X value replaced by some number. So start with 1. If 1 satisfies, then easy. Otherwise go for 2, 3 like that. So X equal to 1 I have to replace. So what I have 12. This 48 I am taking this side. 12 minus 48 is minus 36. Minus 36 divided by 18. True or not, you have to check. So minus 36 is divided by 18. So it is possible. So X not equal to 1. Suppose it is not possible, mean 2 you can try, 3 you can try, like that. So particular solution is X not equal to 1. After that, what is the general solution? What is the general solution rule? Is X equal to X naught plus M by D into T. What is T value? T is an integer. Just replace the value. X equal to X naught value, it is 1v2 plus M value is 18. D value is 6 times T belongs to Z. So X equal to 1 plus 18 by 6 is 3T. T belongs to Z. This is our general solution. And what is the incongruent solution? Next we can find out the incongruent solution. How many incongruent solutions we have? D number of incongruent solutions. So the incongruent solution. Same idea, X equal to 1 plus 3T, the same thing only. But what is T value? T is 0 less than or equal to T less than D. So 0 less than or equal to T less than D value. D is here 6. So less than or equal to 5. So T takes value. T takes values 0, 1, 2, 3, 4, 5. So what is X naught? This implies X equal to 1 possible X. T equal to 0 mean it is 1. T equal to 1 mean it is 4. T equal to 2, it is 7. Next T equal to 3, it is 10. T equal to it is 30. T equal to 5, it is 60. These are the incongruent solution. Now we have the problem. Use the congruence to solve the LDE, linear Diophantine equation. 15x plus 21y equal to 39. Already in lecture 1, we studied about the LDE and how to solve LDE. Now we are using this congruence idea. We are going to solve the LDE. What is given LDE? First I am writing this. 15x plus 21y equal to 39. So 15x minus 39 equal to minus 21y. So this side you have to see, right hand side is minus 21 times y. Okay, so this value is divided by 21 and hence this also divided by 21. So this implies 21 divides 15x minus 39. How you are writing the congruence for this? 21 divides a minus b, mean a congruent to b modulo 21. So here this implies 15x congruent to b value is 39 modulo 21. So we are converting the given LDE into linear congruence. Okay. Now as usual we are solving this. What is a value here? A equal to 15, b equal to 39, c equal to 20. So m equal to 21. So now we are finding D. D is greatest common divisor of A and M, which is equal to A value is 15, M value is 21. What is this value? We can find out here, divided by given numbers 15 and 21. Which number divide both the number? Both are odd number, divided by 3 possible. So 15 divided by 3 is 5, 21 divided by 3 is 7. So which number dividing these both the numbers are prime number? Only one possible. So here only 3 available. So I am writing 3. So GCD is 3. D value equal to 3. Now we are checking whether D divides B or not. So B value 39, D divides 3. D value is 3. So 3 divides 39. So this gives D divides B. Hence 15x congruent to 39 modulo 21 is solvable. Okay. After that we are finding the particular solution. The particular solution we have to check one by one. X not equal to. So in this congruence put x equal to 1. So we are getting 15. 15 minus 39, is it divided by 21? No. Next x equal to 2. X equal to 2 means the left hand side is 30. 30 minus 39. 30 minus 39 minus 9. Is that divided by 21? No. Next x equal to 3. 45 minus 39. 45 minus 39, 6. Not divided by 21. X equal to 4. 60. 60 minus 39 is 21. 21 divided by 21 possible. So I have to take x not equal to 4 by trial, one by one. We have to replace x by 1, whether satisfied or not. X equal to 2, satisfied or not. By trial you can find out. So x not equal to 4. Now what is the general solution? The general solution is x equal to x naught plus m by d times t. T is available in S. T belongs to S. So x equal to x naught value, x naught is 4 plus m value. What is m? M is 21. D value is 3 times t. T belongs to Z. So x naught equal to 4 plus 7t. T is an integer. So x value we found. Now your aim is find the value of y. So substitute in first equation or the given equation. Substitute in given LD. So 15x, what is given LD you have to see? 15x plus 21y equal to 39. In place of x, I have to replace by 4 plus 70. So 15 times x value 4 plus 70 plus 21y equal to 39. Simplify this, what we are having, so 15 times 4 is 60, plus 15 times 7 is 105 times t, plus 21y equal to 39. So after that we are calculating y value. 21y equal to 60, right other side minus 60, plus already we have 39, minus 105 times t. So 21y equal to minus 21 minus 105 times t divided by 21. So y equal to minus 1 minus 5t, t belongs to z. So the general solution of given LDE is x equal to 4 plus 7t, y equal to minus 1 minus 5t, t is any integer.